can only provide mathematical descriptions, since it can only describe patterns within infinite probabilities. When a probability is expressed as C, the information necessary to describe the current moment or probability amplitude of C is also what embodies the arrow of time. The nature of the arrow of time is one of the biggest unsolved problems in physics and has been responsible for many new popular interpretations. The holographic principle, for example, a property of quantum gravity and string theories, theorizes how the entire universe can be seen as an information structure of only 2 dimensions. We traditionally associate the notion of an arrow of time with the sequence of events that we experience through the arrangement of short-term and long-term memories. We can only have memories about the past, and not about the future, and we've always assumed that this reflects the flow of time. Scientists only began to question this logic when discoveries in quantum mechanics demonstrated that some phenomena are not bound by our notion of time, and that our concept of it is nothing more than our perception of the change in observable values. This is also reflected in time dilation and length contraction, which are part of the reason why Einstein established that time and space are the same fabric. In an absolute sense, the notion of time does not differ from the notion of distance. Seconds are equal to light seconds, but cancel each other out. To clarify, with distance and time being each other's opposites, the passing of time can be interpreted as the distance that the hands of a clock travel as they move in a direction that is opposite to time. As they move forward in distance, they effectively travel backwards in what we would call time. This is also why any single separate minimum unit of experience is always instantly annihilated within a timeless now. This understanding sets the record straight between wave function collapse and quantum decoherence. Concepts such as life and death are mere intellectual constructs, and any speculative spiritual ideas of an afterlife that takes place in a realm where the rigid mathematical underpinnings of this reality come to an end are equally fabricated. An important cosmological consequence is that the Big Bang theory, where the universe is traced back to one point by looking at the past, is a misconception. The traditional assumption of space-time, where space is 3-dimensional and time plays the role of a 4th dimension, is inaccurate. If we would want to study the origin of the universe, we would actually have to look forward, since C's time vector direction is opposite to the arrow of distance, from which we perceive an expanding universe. Although this temporal mapping of the universe will only yield abstract concepts with no relation to its quantum underpinnings. Experimental evidence includes the accelerating expanding universe, following what is known to be an inverse or time-reversed black hole metric, as well as the many problems related to the Big Bang theory, such as the horizon problem. These derivations could bring up questions about free will, since awareness seems to only take place after the action within our perception of time. Most neurological investigations that have shed light on this question show that action is indeed taken before becoming conscious of it. But a deterministic point of view is based on an erroneous concept of time, as is illustrated by the